In this example, we want to compute the probability that a simple random sample of size 10 results in a sample mean IQ greater than 110. So this is an example of us utilizing that sampling distribution of X bar that we were discussing and understanding from the previous video. So we need to understand that the first thing is we have a sample size equal to 10. I know that we have a normally distributed IQ score, so the population is normally distributed with a mean of 100 and a standard deviation of 15. Now, what we want to look at is what is the probability that in a sample of size 10 that results in a sample mean X bar greater than 110. And that probability statement here that I just wrote in red comes from the very first sentence of the problem we're looking at. So in order to find this probability, we need to now discuss our sampling distribution. This is where we're going to talk about the shape, the center, and the spread. So the shape that I'm referring to is the shape of our sampling distribution, and because this comes from a normal population, we're okay to go. So that means that the sampling distribution would also be normal. The center of my sampling distribution comes from the fact that the center of my sample means is equal to the population or mean or 100. And the spread of my sample distributions is equal to sigma divided by the square root of n, or in other words, 15 divided by the square root of 10. And I can calculate that out. I'm going to use my Desmos graphic or my calculator over here. So I have 15 divided by the square root of 10, and you can see that that's going to be 4.7434. So we have 4.7434. So for my purposes here, I have information for the mean and the standard deviation that I'm going to put in the normal calculator. So if I go to StatCrunch, since we're looking at a normal distribution, I can use the normal calculator. So calculators, normal. And the mean I'm going to put in is my 100. The standard deviation that I'm going to use is the standard deviation of the sample means, which is what we calculated to be 4.7434. And the probability I'm interested in is the probability of my sample means, which is a variable that's changing each time. The probability that I have a sample mean greater than 110. And when I compute that, we can see that the probability of that happening is about 0.0175. So 0.0175. Now, how do I interpret that? So here you have the interpretation from the probability we just calculated from the normal calculator. So the probability of obtaining a sample mean IQ greater than 110 from a population whose mean is 100 is approximately 0.02 if we were to round that. Another way to interpret what we're talking about is if I were to take 100 samples of size 10 from a population whose mean is 100, we expect 2 of those samples to result in a sample mean greater than 110. So this second sentence here is the interpretation of our probability that we got above. It's what's happening. Remember, we're trying to look at the probability of getting a sample of that size. And so in 100 different samples of this size 10, we think that we're only going to get a sample mean greater than 110 in about 2 out of those 100 samples. And that's how we would interpret this particular problem.